I will look first at hydrogen with itself. So hydrogen is element number 1. So hydrogen has 1 electron, so that's 1 hydrogen. And let's bring in so let's see what would make this hydrogen happy. Remember, hydrogen only has 1 shell, so in the first shell I need 2 electrons for a full shell. For a full first shell, I'm going to need 2 electrons. So hydrogen wants 1 more. Now I like to combine hydrogen with itself, so let's bring in another hydrogen. I'll represent its electron with a dot. Now, what could happen is, if you might say, well, we've learned that we can transfer electrons between atoms. Let's do that. Let's take this electron from hydrogen and give it from purple hydrogen and give it to green hydrogen. Then green hydrogen would be happy, but purple hydrogen wouldn't be happy anymore, because now purple hydrogen has no electrons. And it turns out that that doesn't do. It can't have no electrons. So green hydrogen and purple hydrogen come to a compromise. They say, why don't we share our electrons? And the other hydrogen says, what a brilliant idea. So we'll put our electrons into a bag in the middle, just like a bag of candy, and right in the middle. So green hydrogen's here, purple hydrogen's there, and there's this bag of electrons in the middle that contains 2 electrons. And then they will say, green will say, both these electrons are mine, and purple hydrogen will also say, both electrons belong to me. So you can think of this as, if you've looked at Venn diagrams, you can think of this as a Venn diagram where these 2 electrons are now the property of both the purple hydrogen and the green hydrogen. So this notion of sharing electrons is what defines the covalent bond. It is this attraction. Remember, there are at least protons. Well, there's only 1 proton. There's 1 proton in here that's attracted to the negative electrons here. The positive protons here attracted negative electrons here, and then these positive protons here attracted this negative electron, so that electrostatic attraction is what keeps them in a bond. It keeps them together. So this notion of sharing is, as I like to think about it, is what defines a covalent bonding. Whereas with ionic bonding, we saw that it was the complete transfer of 1 electron, or rather electron or electrons from one atom to another, that causes a difference in charges that cause the bond. So let's go ahead and look at another example. Hopefully clear things up. So I want to look at chlorine now.